Just to make it easier for me, I just put them into groups of 10. So now I see that, well, I was expecting to have 50, or probability said I would have 50. Well, I'm close, but let's see. So 10, 20, 30, 45. Right? So I have 45. And everybody out there is going to have something different. Some might be right at 50, but good chance you'll probably be in the ballpark. But yeah, so for me, the expected number of carbon-14 atoms, well, I expected to have 50, but in actuality, we only ended up with 45. Okay, now, remember, these are still in existence, so these go into the good cup. And then alright, so I'm going to kind of gently shake those up again. Okay, so that was after 5,730 years. They'd found that bone that came from this dog, and now they go ahead and rebury the bone, or the dog, whatever, along with the atoms. Okay, let's suppose another 5,730 years has passed. Okay, so on my chart now, I'm going to start going to my second half-life. So another 5,730 years has passed, so that would be 11,460. Now here's where it gets tricky. So people think, okay, in the first half-life, half of it decays away. So in the second half-life, the other half decays away, and we're going to have 0. No, this is where it's really interesting. Every half-life, half of what you had decays away. So in this first half-life, half of this 100% decayed away to get us 50%. Now in this second half-life, half of that half is going to decay away. So it's not 0, it's half of 50%, which would end up being, no, very good, 25%. Yeah, it's kind of weird how this works. Yeah, so we're going to expect half of that 50% to be in place. Well, so once again, the expected number of carbon-14 atoms, meaning our M&Ms, that also is going to be 25. And so we're pretending 11,460 years later, after this dog had died, somebody's playing in the yard, they find a bone again. Hey, they get it radioactively dated, and let's just lay. So in my case, the 45 that were left, remember, the good cup, I'm only taking them out of here. These have disappeared, or you can eat them as you go. Bake some M&M cookies this afternoon, whatever you want to do. All right, same drill. So I just lay them out. I try not to turn any over. I'm leaving them as they are. I see some M's there, no M's there, and I'm just going to spread them out again. Once again, I've got the M's up over here. These are still carbon-14 atoms. These over here have decayed away. So I'm going to get those and just put them in my decayed away cup. Okay, so once again, put those way off the side. They're out of the picture. And then I'm going to count up my M1s. And once again, it did not come out exactly how probability says it should have. I have 21 left. Come on. Okay, so going back to my chart. So I would have expected to have 25. I have 21. And so write down what you have for that. Okay, then remember, these are still carbon-14 atoms, so I put them back in the good cup. Now we reburied that bone, and so now we're going to go to our third half-life. So I'm going to calculate that out. That would be 17,190 years. Okay, so someone is out playing in the yard 17,190 years after our dog originally died. And the expected percent then, once again, it's half of what we had. Well, we were at 25%, so what's half of 25%? Yeah, 12 and a half, 12.5%. Well, we can't have 12 and a half M&Ms, so expected number of carbon-14 atoms, I'm going to just put 12 to 13, because 12 and a half would be right in the middle. All right, gently shake, pour out your atoms, and split them out again. M's on one side, no M's on the other. And once I've done that, I end up with 2, 4, 6, 8. Okay, I've got 10 that are M up. So my M down ones go in the bad cup, or the decayed away cup, I should say. It's not really anything. And I'm going to just keep going through that process. So, like here, I worked a little ahead. So then, like once I got to my 4th half-life, so I put my 10 M&Ms back in the cup. So I pretended we reburied that bone, come back another 5,730 years later. So now I'm at 22,920 years. You would expect now half of 12.5%, which is 6.25%, meaning, okay, once again, I can't cut M&Ms into halves or fourths because I don't have my chainsaw handy. So I'm just going to say I would expect 6 to 7 of those, but then when I actually poured mine out, I ended up with 5, and keep going on and on and on your own until you finally get to where you have 0 carbon-14 atoms left, meaning you have no M&Ms facing up. All right, so I'm going to go do mine. You go do yours. Pause the video. All right, so I ran out of M&Ms at my 6th half-life, so after 34,380 years, we were expected to have 1.56%, meaning I was expecting to have 1 to 2 M&Ms. I ended up with 0. Some of you will go a lot further than that. And remember, it's all probability, so it's not ever exact. So keep working out until you get to where you have gotten 0 M side up M&Ms left. Take a picture of this if you're doing it by hand and email it to me, or if you're just doing it on the iPad, send me that file, and we're going to find, yeah, everybody's going to work out a little bit better, and that's the whole thing with carbon dating. It is just an exact science, and really, you can only go back to about 35 to 50,000 years somewhat accurately with carbon-14, which is why they couldn't use it on those fossils with the mastodons. They were older than that. All right, so send that to me. Thank you, everybody, and we'll see you tomorrow.